Hi guys, welcome back to Embedded class. So in previous session we have discussed about TM4 series families. So first is what is TMC, what are the blocks in TMC, TM4C and TM4C123. So in this session I am going to explain about TM4C129 microcontroller, right? So this is advanced microcontroller. So we have advanced blocks like CRC for security and Ethernet compared to 123. So remaining blocks are almost all same as TM4C123, and here they have introduced new techniques, new blocks for security purpose. So as earlier we have discussed, so we have system peripherals, serial peripherals and analog peripherals and motion peripherals, and this is nothing but ARM processor. We have 4 blocks in ARM processor. These are called as on-chip modules, and a JTAG meant for debugging purpose, and this is for system controller, system controls and different clock pulses. So we have 2 buses, advanced high performance bus and advanced peripheral bus. So these advanced peripheral bus and advanced high performance bus are, through these buses we have connected all the blocks, system peripherals, communication peripherals, analog peripherals and motion control peripherals to our processor. So what is ETM? Embedded trace macro cells. So this block is decode the instructions coming from the debug. So second block is floating point unit. This is for floating point operations. So NVIC, nested vector interrupt controller. So this block will handles the interrupts. So next is MPC, memory protection unit. It will protects and it will avoid unnecessary memory operations, right? So this MPU, memory protection unit, handles memories. So this is nothing but bus matrix. All the buses are connected to the bus matrix, and we are using SRAM, static RAMs, for data. Okay, so we have 2 types of buses. One is for RAM and one is for ROM. RAM is for data memory and ROM is for instruction memory. So constant data is stored in RAM, so instructions are stored in ROM. So ROM and flash RAM, right? So this is about memories. Okay, so next block is system peripherals. So in system peripherals we have DMA, direct memory access. So we can access the memory directly without the help of CPU. So that is DMA. Second one is watchdog timer. It is a hardware timer which continuously observe the software program. It continuously monitor the software program, right? So we have different types of blocks. Whenever one block is hang state, what a watchdog timer will do is it will reset that block, right? So whatever the block is in hang state, it will reset that block. So we have 2 watchdog timers, and EEPROM for instruction operation, electrically erasable ROM, and GPIOs, so general purpose IOs, hibernation mode. It is mainly for used for low power consumption. So whenever one block is not in use, it will put that block in sleep mode, so that the power consumption is very less. So hibernation module is a device. Through this device we can control we can monitor all the blocks. Whenever one block is not in use, it will automatically switch off that block, so that the power consumption is very less. So next one is general purpose timers. For remaining blocks we need timers. All the timers are connected with the help of general purpose timers. And CRC and external peripherals. CRC, cyclic redundancy code, mainly used for security. This block is not there in 123 block. Okay, so this is 123 block. In 123 block we have only 5 blocks. Sorry, this is system peripherals. We don't have this CRC block and external peripheral blocks in 123. These two blocks are additionally added in 123, so that we have added security device in 123 microcontroller. Okay, so these are the 8 different blocks in system peripherals: DMA, watchdog timer, EEROM, hibernation module, GPIOs, GP, general purpose timers, CRC module, cyclic redundancy code module, external peripherals. And this is nothing but serial peripherals for communication peripherals. So here we added extra block, which is nothing but Ethernet block. Okay, USB, universal synchronous bus, UART, universal asynchronous transmitter and receiver, SSS synchronous serial, and I2C intermediate control, Ethernet and CAN controller. So controller area network controller. These 6 blocks are used for serial communication purpose. And coming to these 2 blocks, analog peripheral, analog to digital or digital to analog converters, analog comparators, and analog 12 channel 12 ADCs, analog to digital converters. And one more peripherals are there, which is nothing but motion control peripherals. We have 2 motion control peripherals, PWM and QEI. So this is the performance of a 123 microcontroller. So core of a processor, core is nothing but microcontroller. We are using ARM Cortex M4 processor. It is a 32-bit RISC processor, and it has load store architecture, and it supports hardwired architecture where data and instruction memory is separate. So the clock and speed, in 123 it uses 120 megahertz operation, whereas in 123 we have 80 megahertz clock. In 129 the clock speed is more, that is 123 megahertz operation and 150 DIMIPS dry stone, 120 million instructions per second in 129 microcontroller. So flash memory is 1024 kilobytes, RAM is 256 KB, EEPROM is 6 KB, and whatever the RAM we are using is loaded with TivaWare for C series software. Okay, these are all advanced compared to 123. So system peripherals, these are the different types of system peripherals we are using: DMAs, general purpose timers, watchdog timers, 2 watchdog timer modules, 32 channel micro DMA controller, so 16 general purpose IO blocks, and EPI, external peripheral interface 16. We can access 16 or 8 or 32 bit. So because it is a thumb 2 instruction set. So 123 microcontroller is using thumb 2 microcontroller. So we can operate the instructions in 8 bit or 16 bit or 32 bit. So for security purpose, we have CRC, cyclic redundancy check module, AES, advanced encryption standard, DES, data encryption standard, and SHS, security purpose. So these are the different types of communication interfaces in TM4C129 UART. So 8 UART channels modules are there. So UART is universal asynchronous receiver or transmitter, means serial to data communication in receiver or and parallel to serial conversion in transmitter. SSI, synchronous serial interface modules, are 4, and I2C, inter-integrated circuit modules, are 10. CAN, controller area network modules, are 2, and USB, universal serial bus. And extra we have Ethernet MAC with media interface independent interface also introduced in TM4C129 microcontroller. So these are the two different types of, these are the different analog peripherals, ADC, two 12-bit ADC and analog comparators and digital comparators. So 3 independent analog comparators and 16 digital comparators. So these are the last blocks, motion control peripherals. So these are used for motors to reduce the power. We use PWM, pulse width modulation, 2 PDM modules. So a PDM module, it controls the power that is supplied to electronic devices in AC and DC motors. And second one is quadrature encoder interface, QEI, 2 QEI modules, and these QEI modules decodes speed and motion sensor information for motors. So mainly for motor purpose to reduce the power, we use these two, pulse PWM and QUE in TMC123 microcontrollers. These are the features in the TMC129 microcontrollers. We have 5 blocks: processor, system peripherals, serial peripherals, analog peripherals, and motion control peripherals. Thank you for watching this.